Assalamualaikum warahmatullahi wabarakatuh. My name is Nursalwa Farahani Binti Mohammad, metric number CE190163. I'm going to present on introduction of soil, temperature and humidity monitoring for plantation. First, in agriculture, soil temperature is an important characteristic since optimum warmth at appropriate depth not only promotes effective plant growth. Due to the importance of soil temperature for seed germination, it also dictates when to sow. Farmers can more effectively organize field activities by studying soil temperatures, earth heat flux, and in particular relationships between wet and dry lands and their heat absorbing capacity. This is why the importance of soil temperature and its humidity is being researched in many scientific domains, particularly biology, physics, chemistry, ecology, agriculture, and economics. So with the creation of such a project of soil temperature and humidity monitoring for plantation, all the consequences that will occur due to imbalance in soil temperature and humidity can be avoided. In addition, crop quality can be improved for marketing purpose. This project can help farmers as well as the public to know the temperature status with notification from LED. Then we proceed to a problem statement. By using soil temperature and humidity monitoring for plantation, all the problem can be solved. It is because the device can detect the temperature and humidity of the soil. We are applying SHT31 sensor which function to detect the changes in temperature and humidity of the soil. So the LED will light up to give the signal that soil temperature and humidity are changing. For this project, the red LED will light up if the soil temperature has exceeded 30 degrees. Then it will turn blue if the temperature is below 25 degrees. While for humidity, the yellow LED will light up if the soil humidity below 22%. Then, while LED will turn on when soil humidity higher than 60%. The objective of this project to alert the farmers on the changing in temperature and humidity of the soil, to apply more technology usage in agriculture sector that can help the farmers to care their plantation. Third, learn high-level programming languages such as C or C++ to learn hardware interfacing and programming methodologies. To improve the abilities and concepts that can be applied the knowledge to develop embedding microcontroller in this project either through simulation or hardware. That's all from me. Thank you.
Hi, Assalamualaikum. My name is Adli bin Nasir, CE1015C. So for simulation part, we so sorry because we don't have any hardware to make a live simulation, live demo. So we have to show the simulator, software simulator only using a simulator.embed. So this project I use 4 output, which is LED as a output and LCD, and then for the input I use HT31 sensor for detect humidity and temperature. So at the code you can see here I declare the input and output here. So we can see here for the output, first line is for LCD, and for sensor, and for output LED until LED4. So LED I use pin number 15 until pin number 18. So at this code, what we can explain is about the temperature. We declare the temperature and humidity and read temperature from the SHT31. Same with the humidity, read from SHT31 sensor. So for the LCD, this is code for LCD. So code LCD is to display the temperature and humidity at the place at the 3, line 3 and cursor number 3 and cursor number 30, which is start at 3 places here and 30 places here. So for the output, we made a code for the output. If the temperature uh, bigger than 30 Celsius, LED 1 will be on, and then LED 2 will be on when the temperature below than 25 Celsius. And for the humidity, LED 3 will on when the humidity soil humidity is below than 20%, and LED 4 will be on where 60% bigger than 60%. So we see now. We see the condition here. The Celsius is 20 Celsius. 20 Celsius, the LED blue will be on pin number 60. So pin number 16 here is LED 2. So LED 2 will on if the temperature below than 25. So below than 25, LED blue will be on. So next is if the Celsius 30 30 and above, the LED red will be on. And for the humidity sensor, so we can see here below than 20, the LED will be on. And if the bigger than 60, the LED white will be on. So that's all for live simulator. So again, we so sorry because we don't have any hardware to show to make a demo. So that's all from me. Thank you.
Hi and Assalamualaikum. My name is Norzari bin Norzari, CE190166. So for my part, I will explain about for the methodology. So basically, methodology from this project consists of flowchart, software, and hardware. So for the flowchart, you can see here we starting from start. Next is sensor has HT31 is on and LCD is on. Next, sensor has HT31 start read temperature and humidity. If the temperature greater than 30 Celsius and humidity is larger than 60%, the LED 1 will turn on and the LED 4 will turn on. And if the temperature is below than 25 Celsius and humidity is below than 20%, LED 2 will turn on and the LED 3 will turn on. Next, LCD display the reading from the sensor has HT31 and N. Next is software. So we are using Embed Simulator as our main simulator for the software to run this experiment. The simulator allows you to run your Embed OS 5 application directly on your computer so that you can quickly test and verify application without flashing them on an actual board. This Embed Simulator is written in the C++ programming language as an instruction code that will be executed to the component when it is in run status. Basically, in our code, we are using include as a header file to declare all the components that we are using, like embed controller, LCD, and temperature sensor. Other than that, we also use float in our program as its function on our LCD. It is a fundamental data type built into a compiler that defines numeric value with floating decimal point. For example, in our project indicates the value on the LCD for the result. Furthermore, we use the function while because the while loop statement in C++ allow you to run the same blocks of code over and over until a condition is met. In C++, the while loop is most fundamental. The while loop has only one control condition and run if it's true. Next is hardware. So we're using Embed LPC1768 microcontroller. The Embed LPC1768 microcontroller is designed for prototyping all sort of device, especially those including Ethernet, USB, and the flexibility of lot of peripheral interface and flash memory. It is packaged as model IP form factor for prototyping with true whole PCB, strip board, and breadboard, and include a built-in USB flash programmer with a 32 bits ARM Cortex-M3 core running at 96 MHz. It includes 512 KB flash and 32 KB RAM, and a lot of interface including built-in internet, USB host and device, CAN, SPI, and 12C, and so on. The pinout commonly used interface and their location, all the number pins like P5 to P30 can also be used as a digital in and digital out interfaces. Next is temperature and humidity sensor, which is HHT31. So HHT31 is a temperature and humidity sensor that is highly independent, accurate, and quick to respond. This model usually accuracy is 2% relative humidity and 0.3 degrees Celsius for the temperature, which is plus minus. This module is compatible with 3.3 volt and to 5 volts and hence does not require a voltage level shifter and is communicate using with 12C series bus and can work up to 1 MHz speeds. It will also include a heavily abstracted library to make this product even more user-friendly. Next is liquid crystal display, or we call LCD. The LCD is a type of display that use liquid crystals for its operation. Here, it will accept the serial input from the computer and upload the sketch to the microcontroller. The character will be displayed on the LCD. This type of display has a capability to display 224 different sort of character and symbol and is normally powered by 5-volt voltage supply source. Next is light emitting diode, which is LED. So LED are the latest development in the lighting industry, made popular by their efficiency, rate of color, and long lifespan. LED lights are ideal for numerous applications, including night lighting, art lighting, and outdoor lighting. It is a semiconductor device that emits infrared or visible light when charged with an electric current. In conclusion, the words humidity and temperature has begun to draw more attention from many scientists and researchers. Monitoring the humidity and temperature is a fabulous technique to record and track any changes to enable the decision maker to prepare or follow the proper procedure to prevent any environmental disaster that could risk the natural resources, especially soil, due to the imbalance in temperature and humidity. By doing this project, we can alert the farmer on the changing the temperature and humidity for the soil. By that, it will help improve the production of the products, for example, vegetable, fruit, and so on. Furthermore, this project technique reduce the overall system cost, provide real-time observation, low power consumption, lively tracking, real-time data processing, and analysis. Other than that, this project can help us improve the ability and concept that can be applied to develop the embedded microcontroller in this project, either through simulation or hardware. I think that's all from us. Thank you.